Hi, my name's Scott Fincher. I'm a data scientist with NIME, and I was asked to come into the Hub Data Coffee today to talk a little bit about technology strategy, and in particular, how we could connect different personas that it might be in a company during a data science project. How would these different personas use different facets of NIME software to get their work done in an effective way? So I'll start first by talking a little bit about what a sample data science project might look like. Then we'll move into the personas, what those folks are, and then I'll show you some of the features of NIME Analytics Platform and NIME Server that are going to apply to those folks. So maybe you recognize this. This is the CRISP-DM diagram, the cross-industry standard process for data mining. So this is kind of an outline of how a generic data science project might go, right? You start in the top left corner, you're going to have some business question, some question that you're trying to answer, and hopefully you're going to have some sort of data that's associated with that question that will help you get there. So you have a business understanding, a data understanding. You need to do some preparation of your data to get it in line for actually doing some sort of predictive modeling with it. Once you develop a model, then you're going to need to evaluate and see how well did that model perform. Did it actually predict what I thought it should? Do I need to go back to square one completely? Maybe that's the case, in which case maybe I need to think about my data, or even if the question that I was asking in the first place was worthwhile at all. But assuming I can come up with a model that evaluates nicely, then I've got something that I would then want to put into deployment. So another way that you might think about the CRISP-DM process is to unroll it. And you can see this here. This actually, if you're familiar with NIME Analytics Platform, starts to sort of look like a workflow a little bit. So we're going to start with some sort of data in our data science project. And then there's things that we need to do to the data along the way, right? We're going to need to, blend it together. We're going to need to generate some features or reduce dimensionality, deal with outliers, all these sorts of things that we need to do to dirty data, right? It's never pristine when we get it. We need to clean it up in some way. So that's the data preparation phase that a data scientist probably is going to be undertaking, right? And then we're going to partition that data and move on to model training. We're going to need to select the appropriate type of algorithm for the problem that we're trying to solve. So, if we're looking at classification, then maybe we need to, use random forest, for example. If we're looking at a clustering problem, then we need to use k-means. Whatever it is, we need to select some sort of model and then determine whether an individual model or an ensemble of models is going to be the best approach to predicting whatever it is we want to predict. So once we make some selections about the model we want to use, ultimately we'll need to optimize it. This is going to be called, you may have heard it referred to as parameter tuning, or maybe a grid search. And all of these little bells and whistles, knobs and dials that we need to tweak to get just the most optimized version of the output from the model that we can. So we'll do that, and then in the model evaluation, we're going to be looking at some sort of measure that indicates how well our model performs. Maybe it's something simple like, accuracy in terms of classification, maybe looking at a ROC curve, doing some cross-validation. There's a bunch of different ways that we could set things up to evaluate how our model is doing. And then once we're satisfied that the model is actually performing the way we think it should, then we've got a deployment. During deployment, maybe it's going to be just writing out files, doing some sort of reporting. Maybe it's going to be something more sophisticated like an interactive dashboard, or maybe we'd like to have our model stood up somewhere and then use REST API to call it and get predictions really quickly. All sorts of things that we could do in the deployment phase. So this is the unrolled version of what a data science project might look like. So what's going on in the data science project and who is going to be doing these different things? So let's talk a little bit about the roles in this type of project. Pretty much everything that I mentioned before with CRISP-DM is going to apply to the data scientist. Not all of it, but most of it, probably up to the deployment part anyway. This is the person who's going to be developing the workflow. Actually coming up with, if you think about a NIME workflow, he's going to be dragging and dropping in the nodes. He's going to be iterating on the model development. All that stuff is going to fall into, what he's trying to do. Now, we also would have someone, a business analyst. This is going to be someone who maybe doesn't have the technical expertise that the data scientist does about things like algorithms and whatnot. But the key about the business analyst is they almost certainly are going to have the domain knowledge an understanding of the data set, which is super important, right? The data scientist may not necessarily have that background about the data that he's looking at. He knows, the algorithms and so forth. So we need to combine the knowledge and the expertise of these two folks to be able to ultimately make business decisions, which is going to be useful. That's the whole point of doing the data science project in the first place, right? Is to come to some concrete business decision. And then someone who's kind of in the background, but is no less important, the IT administrator role. This is someone who is going to be setting up the servers, making sure that we have the architecture in place to be able to do these analyses in an effective way, whether it's on-prem or in the cloud. Someone who's going to be making sure that folks have access to the data that are supposed to, and that the folks who shouldn't have access don't. This is a very important person as well. So all three of these folks, we have ways to assist them with KNIME software. We'll talk about that here in a little bit, but first some more on these individuals. So a data scientist, he's going to be creating and updating these workflows. He may, and hopefully is creating and maintaining what we in KNIME call components, which are portions of workflows. Like if you're used to programming, you can think of them almost as functions, little groups of nodes that perform an individual task. He's probably going to be doing some sort of reporting. We'll certainly be building some predictive models in this case of the data science project. He may be doing one-off ad hoc developed workflows, or he may be regularly scheduling a series of workflows depending on how things are going. But he's going to be the one that's developing what's going on, the workflow behind that underlays all the stuff for the data science project. He may also be cooperating with hardcore coders, people who are building stuff from scratch in Python or R, and more casual users depending on their level of expertise. Now, the business analyst, what's this person going to be doing? So his whole main goal here is to extract insight from the data and then be able to make business decisions based on those insights, with the goal to improve the business process, right? That's the whole point of this data science project, is we can come to a decision at the end that's going to result in something that's good for the business. So this person, as I mentioned before, may not have the technical expertise that the data scientist does, but he has the domain knowledge. So we want this person to be able to apply their domain knowledge in a way that's an effective use of his time. This person, we may not, want them to learn additional software. We could put a dashboard in front of them that we deploy using a web page to allow them to interact with the analysis in a useful way. And I'll show a little bit more about that in a minute. And then finally, the IT administrators, we talked about, they're setting up all the servers. They've got to do updates, bug fixes, manage all the permissions and backups and all that sort of stuff. So we have tools for them too. So how can KNIME software work for each of these people? So let's talk a little bit more about what KNIME software, the entire domain, looks like. So if we start in the middle of this diagram here, we have KNIME Analytics Platform. This is the freely available open source version that anybody can download. And this is what is going to be used by the data scientist to load, integrate, transform, analyze, and visualize data. That's what you see across the top of the diagram there. Blending in data from different sources, building models, producing reports. That's all done with KNIME Analytics Platform. Now we have some of the stuff on the side here, the integrations and extensions. Those are all freely available. Well, everything except the partner extensions I'll talk about in a second. Those are freely available, open source as well. It's just that if you need to do a specific type of analysis, let's say you're doing NLP, text processing or image processing, you might need to download some additional features, KNIME extensions, to be able to use that. Still going to be freely available to you, but it just doesn't come with the default download. We also have some community extensions, extensions that have been developed outside of KNIME, but have been made publicly available to everyone. And then there are some of our partners who will produce commercial extensions for things like web scraping, or perhaps access to particular types of commercial databases. They'll offer those extensions for a fee. And then everything we're mentioning here on the top associated with KNIME Analytics Platform is sitting on top of the KNIME server. So the KNIME server has different roles that it supports, or I should say functions rather than roles, really. The collaborate, automate, manage, and deploy along the bottom. This is all facilitated by the KNIME server. So we're talking about data scientists again, whether they're algorithm developers, or they're data analysts who have scripts in R and Python that they just want to deploy in a more visual way. If they're data wranglers who are blending data from databases and flat files, a bunch of different sources together, kind of an ETL function, or if they're workflow recyclers, folks who actually already have their workflows built, they just need to execute them, regularly in a defined way. NIME Analytics Platform is going to support all of these types of data scientists. We give them some additional capabilities as well. The ability to share components. One of the really nice features about NIME is that, let's say I build a little workflow or a portion of a workflow that I want to reuse in a bunch of other different workflows. Maybe, I have an Oracle database I need to reach out and touch with a particular set of login credentials, and I want to choose from 2 or 3 different tables to load data from. And it's something that I do all the time in most of my workflows. Then I could build a component to do that for me, save it in NIME Analytics Platform, and I could even share it with other data scientists on my team, just so we don't have to come up with that from scratch every time, right? I do it once, make sure that it works properly, and then for my future workflows, I grab it and bring it in. Some other tools around local automation so that I could execute workflows via batch locally on my machine, and then the workflow diff, which I'll talk about more in a little bit later. So when we're talking about NIME Analytics Platform, whether we're blending from a bunch of these different sources, whether we're coming up with some sort of predictive models, developing machine learning, or maybe it's deep learning, artificial intelligence type stuff, all of that kind of falls under the umbrella of what we would call data science. And we're calling the role of data scientist here. So you may hear them referred to as data engineers or app developers or ML engineers, whatever people want to call them. We'll call them data scientists here, and we think about them using Analytics Platform and the associated integrations and extensions. So what about our other folks? So we've got other people on our team that are not data scientists that are crucial to the success of the data science project. In particular, the business analysts who we mentioned, who are trying to make business decisions based on the data and the models that are available, and upper management, right? They've got to sign off on the results of these analyses to actually put them into place. And then also IT management and compliance folks. All critical members of the team, all people that have different needs, and all people that we can cater to with different aspects of NIME software. So for these last 2 groups, the business analysts and the IT folks, maybe NIME Server is going to be more useful for them. And so if we think about NIME Server and the concepts of collaboration, automation, management, and deployment, putting all that stuff together to be able to generate value for other folks who are not associated with a data science team, right? People who need sales and marketing reports, financial information. Maybe there's manufacturing folks that need to keep an eye, or they need to keep an eye on what's happening in real time with their sensors, IoT sort of stuff, make sure that the assembly line's up and running. All of that is, these are all folks that are outside the data science team that can still benefit from the data science project, right? But in order for them to benefit from it, we need to use NIME Server to deploy our models in a way that's useful for them. So when we talk about these 4 different functions of NIME Server, when we say collaborate, we're talking about the ability to share not only workflows, but also components, nodes, and even data amongst folks on the data science project team in an effective way. So instead of, just like emailing or putting workflows on a shared drive, we actually have NIME Server which can help us govern access to all of that information. Automation is also super important in terms of scheduling execution of workflows, but also managing our computing resources in an efficient way. So making sure that we have the right CPU and RAM available for workflows that are maybe take longer to run or require a lot of resources. That's all stuff that we can manage using NIME Server. Security, super important, right? Making sure that people who shouldn't have access to data and workflows don't, and that the people who do need particular access do have it. Being able to maintain some control over configuration of both the server and the analytics platform, as well as some version control. That's all stuff that NIME Server can help you deal with as an IT admin type of person. And then finally, deployment, that last step of the analytics process, and arguably the most important. how are we going to get the results of our model out there so that other people can consume it? So we could use the web portal, which I'll show you here in a second, to do that, an interactive way of dealing with workflows via your web browser, but also things like a REST API or making touch points to be able to interact with other applications. Let me just show you a few things about the web portal here. So if you haven't seen it before, this is the prime use case for our business analyst, someone who is not going to be building workflows with nodes in KNIME, but someone who needs to execute those workflows. So he can do it via his web browser if he loads up the web portal, which is going to be running on the KNIME server. So if he were to load that up, you can see a web browser window here. He gets a list of all of his workflows, and then he can click Start to execute whichever workflow he wants. And then depending on what's being provided as part of the workflow, there's going to be some sort of interaction point. Like in this particular case, we're allowing the business analyst to select the number of clusters in a cluster analysis, as well as the columns that he might want to cluster on. Those choices have been predefined by the data scientist who designed the workflow. And we're handing that control off now to the business analyst, someone with domain knowledge, to be able to make effective decisions about how the analysis should proceed. We call this guided analytics. If you're interested in this whole process, we have several videos on our YouTube channel that do a deep dive on how this works, along with some really complex and really cool looking workflows. So I'd encourage you to check that out if this is a method of deployment that would be useful to you and your clients. So just digging a little bit into the concept of guided analytics, if we have a workflow here, this has been designed by a data scientist to load in some data on the left-hand side. In the middle, we're building some sort of model. On the right-hand side, we're going to be deploying the model and creating some visualizations, right? This is useful for the data scientist, but for the business analyst, this probably is pretty meaningless to him, right? So if we were to take this and run it in the web portal, we can give the business analyst what are called interaction points. So at each one of these components, these gray boxes, this is going to allow the business analyst some ability to change something about how the workflow is proceeding. So if we zoom out a little bit, we still have the same workflow. Let's say we wanted to focus in on this single component for user feedback. What's actually going on here? Well, from the data scientist perspective with analytics platform, it's going to look like this. We have some workflow that is taking some data and creating some visualizations, basically a sunburst chart, decision tree view, parallel coordinates, a box plot, and allows for some other things down here, some different items that the business user can choose. So this is what the data scientist is going to see. When the business analyst runs this within the web portal, this is what the business analyst sees. He sees the results of this executed workflow. So he's got the sunburst chart over here, decision tree, parallel coordinates, and so on, the ability to choose which of these features he wants to model. And so, the idea being, right, that he can look at the results of this and say, oh, I need to make changes A, B, X, and Y to proceed with the modeling. Then he clicks next and he goes on about his merry way. But all he's seeing is this bit on the left. He's seeing the dashboard representation as a business analyst that the data scientist has prepared for him. So stepping away from that, since we're a little short on time, I just wanted to cover some of the IT admin features again. Useful stuff for the IT admin side, things like remotely executing workflows and scheduling them at particular times, being able to control who has access to data and workflows and how to authenticate folks who are going to try and access, version control, several of those other features. This is kind of a busy slide, but it shows you, for example, how the scheduling might work. If I have something that a workflow I'd like to execute overnight so it's not clogging up the server when other people are trying to use it, or maybe I have a workflow that needs to run, every hour on the hour on particular days or something. That's the level of detail I have available to me to be able to schedule workflows on the server and do it remotely. Also interface for setting permissions. We talked about this, but if I have different groups defined in my KNIME server of particular users, I can say, the marketing folks don't get access to the dev information or, whatever. That's all completely customizable. And then version control and snapshots as well. If my data scientist is creating snapshots as he goes, he's developing his workflows, If he gets to a point where he decides, ugh, this isn't working for me, I should really roll back to what I was doing on Monday. If you're using the snapshots, you can actually go back and help him do that, just to maintain control over what versions of different workflows are on the server. And then also the 9 workflow difference. This gives you the ability as a data scientist to compare different versions of workflows. Where did this node come from? Why did I put it in here? How is it different from this other node? These are all things that I can identify. So particularly useful if you're trying to troubleshoot a model that's in deployment. If something has changed and you're not sure why, you can get this very detailed look into your workflows of how they're different from one another. So in the interest of time, I will stop there. I understand in October, we're going to have a live short Q&A about what I've presented here. So I'll be available for that to take your questions. If you have any questions just as you've been watching this, just note them down and I'll answer them then. I'm happy to share these slides with folks as well. Thanks for the opportunity to prepare this for you.